Okay, hi folks. So here is an electric kiln. This kiln is engineered to turn electricity into heat, and we do it the same way we do it in your hot water heater or your toaster. So inside the kiln, on the sides, are elements, like little pieces of wire that electricity goes through with a bunch of resistance, and that creates heat inside of this chamber. Right, so you can see a stirrup vessel down there that a student was working on, and now we got it in the kiln. This whole place is going to get filled up with kiln shells, like you see below here, to the top, and then we fire it. Right. So what keeps the heat in and the cold out is this stuff here, which is called soft brick. It has burnable materials that when the bricks are made, those materials burn out, go away, and it leaves little voids in the brick, and that makes it insulate, right? So like how the air spaces between feathers in a down blanket create, good insulation and reflect your heat back to you. That's true of this as well, right? So we can be, 1,000, 2,000 degrees inside here, but only be a few hundred degrees outside of here, right? This one and many of the kilns that we see today has an electronic controller on it, so we can do things like change how fast we make heat, or how fast we get to temperature, how many degrees it goes to, how many degrees it's supposed to sort of hold for a little while, right? For example, if you fire a kiln really fast between 900 degrees and 1200 degrees, you can ruin the pots, essentially. They'll break because of sort of a chemical process that happens at that temperature within the clay, right? So yeah, we call these refractories, bricks that are good with heat, shelves that are good with heat. So the refractory roof here goes down, and then we fire this kiln, and it kind of sounds like a big microwave when we're poking away at it to put in a firing profile, right? So it takes a long time. For bisque firing, we like to add a little extra time on there in case there's a little extra water in the work. If you put wet pots in this kiln and just have it go right away, the pots will explode and get everywhere. So we kind of, make it so not so much heat happens early on. And that way the pots have a chance to dry out, right? Okay, once they're fired, they become a thing called bisqueware. Before they're fired, like the dragon guy down there, it's called greenware. All right, so this is a piece of bisqueware, and you can see that it's orange like that. Same clay as this piece down here, but it's fired now. It's no longer clay. We can't break this down anymore and make it stretchy anymore. All right, so it's ceramic now. So it's fired to 1,645 degrees, and that is the good bisque temperature for the clay to still be porous enough so that when we put on glaze, it goes into the pot and sticks on the outside, and it's really, a good temperature for good application of the glaze on there, right? So what we would do next is we would fire this a second time with some glaze on the surface, and then it would end up with a glass-like surface, like some of these, right? Get my phone to catch up. So this is glaze. We evaluate glaze in 4 fundamental ways. The first way is transparency, right? So some glazes we can see right through, like this one here, for example. That's what the clay looks like underneath a clear glaze. It's not a brown glaze. It's just a clear glaze on top of the red clay. That's what you get. Okay? So we evaluate it for transparency. We want to know if we want to have a glaze we can see right through, or one that's a little harder to see through, or one that's opaque where we can't see through at all, like that kind of white pink guy back there, right? The next thing we evaluate glaze on is texture, right? So most of these guys are shiny, as are most of your low fire glazes, right? Very shiny, smooth. But we can also get different textures, matte, semi-matte, right? So we can see on here, it's not as shiny, right? And there's a little bit of texture to it. This translates terribly on camera, but there it is, right? The next thing is temperature. Like, we got to make sure all the glazes go to the correct temperature we're going to bring all the pots to. We can't have a whole bunch of rogue temperature glazes all in amongst each other, or some will melt too much, some won't melt at all, right? And then we also evaluate it by color, right? So back here, our clear glaze, there's no colorant in here, so it's kind of drab. The rest of these guys here, and there are many more, all have colorants in them. And colorants are, you know, just small amounts of metals and minerals that give, you know, the glaze its color. So that's the 4 ways we kind of evaluate glaze. And you might ask, what exactly is glaze? Glaze is made up of 4 components, 4 really important components. One, silica, which is glass, right? The glass in your windows right now, the glass on your phone that you're maybe looking at this on, that's silica glass, right? Glaze also has alumina in it. Alumina is present in clay too. And to help the glaze and clay fit together, we have alumina in there. And we have a melter. Okay, so silica and alumina both fire to really high temperatures. Silica is 3,100 degrees, and alumina is 5,700 degrees. So that's too hot. So to bring that temperature down, we add things that makes the glaze melt at a lower temperature. They're called melters or fluxes, and there are a bunch of them. And all of them bring special attributes to the glaze, you know. Like, some of them can make it more shiny or matte. Some of them are really good for color, you know. Some of them just make a really good surface. So yeah, we're thinking about our melters when we mix it with the alumina and silica. And then the 4th thing is color. So some glazes, like our clear again, don't have a colorant in them. So it's only, you know, basically those 3 things. Just real briefly, the alumina and the silica and the melter, those guys are all included in many materials. So what we do is we make a recipe of those of specific materials. Like, for example, a thing called Custer feldspar comes from Custer, Wyoming. You know, I've been to the factory there. It's they're there grinding up a kind of feldspar, putting it in bags, and sending it out to us. Maybe I'll do a little video of some of that too. So yeah, the silica and alumina and melter all come in materials that are mined across the United States or the world, right? So that's this very short answer to what is glaze, right? We evaluate it in the 4 ways: transparency, texture, temperature, and color. And we make glaze with silica, alumina, melter, and sometimes colorant. Okay. So over here are slips. And slips are just clay with a whole lot of water in them, right? They're in these little buckets here. You know, when they're stirred up, right? And we apply those first onto bisqueware if we want to kind of change the color of the glaze, right? So for example, down here on the end, all of this group has orange slip on the bottom of it, or on the first layer, right? You can see some of it kind of sneaking out underneath here. And then we applied every one of the glazes on top of those that glaze, right? So we have 7 glazes, so we have 7 examples of what those glazes each look like on top of the orange slip there, right? Same thing for several of them going on down the line. That's a way that you can manipulate color and sometimes texture by putting on a different color slip, on top of the clay, but below the glaze, right? Yeah, always first slip, then glaze. Okay? So that's the short version of clay and glazes.